You did, man. Yeah, last time was a cool class, man. That can happen. I know, it's crazy. So we basically took a circle and we stuffed it into a rectangle and then found the area of the rectangle. It's crazy. So you missed out if you weren't here. Circumference of a circle, that kind of stuff. You know, so I'll have to figure out how much I want you to know. I mean, you should know the circumference of a circle. You should know that. You should know the area of a circle. You should know that. You should know the formula. Something like the volumes get a little bit more freaky. So maybe I'll let you guys have some volume formulas. Okay, so let's get back into 9.4. Any questions, first off, from any homework stuff? Yeah?
Where did you get that shirt?
I have had this shirt for so long. I think I just got it from Cafe Press or something like that. There's a website called Jinx that I get some stuff from. It's like a gamer site for the most part. They got geek stuff up there too, like Hitchhiker's Guide stuff. I had this 42 shirt, and I had people like, what's 42? Something special about 42? Yeah, something's very special about 42. You guys know what's special about 42?
Yeah, it's the answer to the universe.
Yeah, life, the universe, and everything.
No one knows the question.
Well, they figured the question out.
Yeah.
Do you know what the question was? What is 6 times 9? That was the question. You have to read far enough in the series.
I never read.
I'm like geek of another level. All right, so everybody that has no idea what we're talking about, I'm really sorry. I'm really, really sorry. Some of you guys are like, that's the way I always feel in this class, man, so it's fine. It fits right in.
Yeah, where'd you get your shirt?
Walmart.
Yeah.
Sweet. It's on sale, 3 for 20.
That's right.
Wait,
Shouldn't it be 4 for 20?
no, it's 3 for 20. I don't know Walmart. I do know that I got 3 of the exact same flannels there.
The same color?
Same color.
I like less decision making. Yes.
Is it just supposed to be ironic, or is there some artifice, or what? It's because it's obviously not 42.
Obviously not.
So what is?
That's what I love about it. And Douglas Adams himself, the guy who wrote the thing, said he didn't really pick it for any specific reason. It's just cool. It's just the fact that people try to find what they want in it. He could have picked any number, and people would have had theories.
Try
And he's like, the answer is, I don't know. I just picked a number. It was awesome.
The whole life and death thing is 42.
For what now?
The answer to the question of the universe is, what is the purpose of life? 42, which in Japanese is shi and ni, which is shi together, which is death. The purpose of life is death.
See? There's theories like that everywhere. Anyway, all right. And the answer is, he didn't really pick it for any reason.
Right? Finding patterns. Finding
Exactly. Like the numerology of the Bible,
Right.
right? You go every 8th letter and it tells you to jump off a building or something. Or that you will jump off a building on April 20th.
Wait, is that true?
I haven't done it yet, but the day's young.
Which?
All right, let's leave all that to the side. That's a little bit beyond the curriculum, right? Or to the side of the curriculum, I think, is the appropriate way to look at it. Okay, so last time we talked about, this guy. And then the idea of this guy, someday I'm going to get students to understand what I'm about to tell you. So this is a challenge. This volume is, what's the volume of this shape here?
LWH.
Which for me, that's an awesome drawing for me. LW. And what is LW by itself?
The base.
The area of the base. And think about, and if you were here last time we talked about this, if I stack a bunch of, and I said something, records, right? But let's go with, screw it. You guys know what records are. They're coming back.
Pizza
You
box.
stack a bunch of records, pizza boxes, whatever. I want something more flat. And I have this many of them stacked up, then the volume that they pass through will be LW times H. That's the idea. So anything that has a repeated shape, like cookie dough, right? You buy some cookie dough, the repeated shape is a circle, right? So if I have, and so it makes the shape of a cylinder. So what would the volume be? Well, what's the area of the base? We call that big ass B. What's the area of the base? So let me give you some stuff. There's the radius of the base. So what's the area of the base? Pi r squared. That's right. And let's say it's h tall. So what's the volume then? It's going to be the repeated shape area, pi r squared. How many circles are stacked up on each other? H of them. So the total volume it passes through is pi r squared h. Let that be awesome. So here's a concrete application of this. Right? Let's say I have I think we talked about this last time too. Toblerone. Let's say I put it on its end like this, right? All right. Let's deal with my horrible drawing. Now let's say this triangle has height 3 and the base is, let's say 7, and the length of the Toblerone is, we'll say 16. And I won't even tell you what units are. So how do I find the volume of this? Do I need a formula? No, all I need, the only formula I need is big ass B times H. Let me see if you guys have been paying attention to the last minute. When am I allowed to use this? When what is happening? When I have a shape? Repeated. I like it. So could this work for a cone? No, the shape is not repeated. The circle gets smaller as you go down. Right there, the circle's smaller as it goes to a point. You with me? So this formula only works for repeated shapes. Does that make sense? Does everybody understand what I mean by repeated shapes? If I chop it anywhere along, it's going to look like a triangle there, right? If I chop this, it's going to look like a circle. If I chop, well, this is out. Too bad to go away. The same size circle, the same size triangle. That's the point. So I'm just going to multiply how many of those I've got stacked up, and that's the total volume. I love that idea. So what's the area of the base? What's the area of that triangle there?
1/2 B.
Yeah, 1/2. 7 times 3. So that's big B. That's big ass B times the height of the repeated shapes. 16. That's how tall it is, right? So the area of the base, which I call big ass B, is not little b. Little b is just a line. It's just a base of something, right? That's what little b is. Big ass B is a whole area, but it's acting like the base to this 3D object. Okay, well, shit. And then you just do, I would do half of 16 is 8. And then 8 times this business. 168. I like it. Cubic whatever units. I like that. Cool. How are you guys doing so far? So I could give you a shape like, here's one I gave my, now I had my students do some more stuff with this beyond what we're going to do, so don't freak out. But I gave my calculus students the shape, and they still joke about the trough problem, the evil trough problem. So I had this trough with the trapezoidal base, right? Yeah, screw it, Jeff, let it go. You can't draw or shit, so it's all right, buddy. So this trapezoidal base repeated throughout, right? So at the end, it still has that trapezoidal base on the other end. That is horrific, but we'll be all right. We'll get through this. Let's say it's. Say again?
You're missing a whole line.
I am, but I'm not sure how to bring it in. Where are my artists? Are you out there? It feels like cheating because my perspective is weird. Screw it. So let's say this is 8.
It's not even a.
I said let's get past it. Please get past it. Let it go. What am I not teaching?
What?
Art. Thank God.
Clearly.
I didn't say what are you not learning. I said what am I not teaching?
Well,
So let's say that this is 6, and let's say that this height here is 2. And of course I need one more thing. I need this guy. Let's say he's 3. Wow, sounds good to me. So what's big ass B in this case? What's the repeated shape?
trapezoid.
Trapezoid. So I love it. So what's big ass B? What's the formula for the area?
Isn't it like 1/2
Yeah.
B1 plus 1/2 B2?
Almost. You're just missing the H.
Oh, yeah.
So it's just like a triangle, except it's got 2 bases. It's that poor triangle that got decapitated. Right. Let them eat cake. No triangle. So what's the height of the trapezoid?
2.
2. And then the bases are 6 and 3. You guys kind of with me? So when I finish what I've got up on the board so far, what is that going to be? Big ass B, which is the base area. So to get the volume, I'm going to take that and multiply it by how much that shape appears. It shows up over a course of 8, over a length of 8. So I'm going to multiply by 8. What's that?
But there's a problem.
No, there isn't.
Oh,
Why?
it's a chalk problem.
Oh, well, again, I said it was my calculus student. So they had to do calculus with something. I was filling it with a liquid at a certain rate, and they had to figure out how quickly the height was rising at a certain time. So that's calculus. Calculus is all about rates of change.
Why do math majors hate themselves?
What do you mean? You're right. You said something that was almost made sense. I like that. Vaguely funny. So if this was 6 feet, 2 feet, 3 feet, what would this be?
9 feet. It's cubed.
Cubed. I like it. So it's your volume, so it's got to be cubic feet. So that's, well, it's not volume yet, so this would be what?
Square.
Square. So that's area. All right, so this is area of the base. So how do I get the volume?
You multiply by 8.
Yeah, you multiply by how often that
the
shape shows
height
up.
to the
Hold up.
length.
So this will be 9 times 8. So it's big B times H. Kick ass. Because that's how much that trapezoid shows up. So of course that'll be 72. I was so excited. Now it would be
feet cubed.
cubic feet, because it's square feet times feet makes it cubic feet.
So if you were filling that at a constant rate with water, how do you figure that? What's the equation?
Take Math 180. That's like a
It's a
cliffhanger.
trap. Don't do it.
I get it because it's a trapezoid
Admiral.
too.
May you rest in peace.
I like that. That was good. All right.
Too soon?
What's that? Oh, Admiral.
Yeah, the voice actor died.
Yeah. The voice actor for Admiral Akbar from Star Wars. The one that said, "It's a trap." No. Okay. All right.
The weird squid-looking guy.
Your lack of geekiness disturbs me.
Give a shit
All right. So guys, do you guys get this idea? So I can give you some weird ass shape. As long as you know the area formula for that shape and it's repeated, you can get the volume of the whole thing. You just multiply the area of the base times how long it shows up. That idea is freaking awesome. Now the next level of this we sort of got into last time. If I take any prism, this is why I haven't used this word yet, but any repeated shape like this is officially called a prism. These are prisms. So the volume of these prisms are B times H. So the most simple next level I could do, the next level would be pyramids. The most simple next level I could do would be, we did this last time. So this volume would be length with height, but if I cut out of this a pyramid, and what a pyramid is, the official definition would be take all the corners of your shape and have them meet at one point on the top. And again, for me, that's really damn good. So if you don't think so, you're wrong. Just to let you know. The really cool thing, no matter what the shape of the prism, if you do this, the pyramid that results is 1/3 the volume of the whole thing. So visually, that's hard to see, but can you imagine there's a lot of empty space around it. If I take all the stuff out that's around the pyramid and just leave the pyramid, I just took a lot of stuff out because it's all the way around it. So I took out 2/3 of what was there, so the pyramid is 1/3 of what was there. That's what's left. So the volume of this pyramid would be 1/3 length with height. So the volume of any pyramid will be 1/3 big ass B times H. Because any pyramid is 1/3 of the prism that it was cut out of. Maybe.
But then, are you given the pristine shape, or do you have to infer it with the pyramid?
Yeah, they're going to be giving you the shape, the original shape. Right? And in fact, you can have a pyramid, you don't have to be given the original shape, you just have to know that it's a pyramid. So for example, if I gave you this shape, let me see, this is going to be scary for me. Which automatically means it's scary for you too. That's really bad.
Kite?
That looks like a kite. This is true. I'm not going to be able to draw it so it looks like anything other than a kite. But oh well, I'm going to try again, aren't I? So this is a pyramid where the base is a triangle. This is the base. And I've connected all the sides to one point on the
Is
top.
that an aerial view? Like the
Well, an aerial view would be like this. That would be the aerial view, right?
Then what the heck is that?
That's from the side, right?
What?
All right. Are we okay? I mean, it's not the best picture that anyone's ever drawn in the history of the world, but it's not that bad.
What side are we looking at?
So this is the base, right? That's the base. So we take that line away. Okay, that'll help out a little bit. How's that? There's one face that we can't see on the other side.
I mean,
That's
if
all.
it's going underground, well, I don't.
No,
Okay,
it's
we'll
floating
just go
actually.
with it. Let's
It's
just go with
it's
it.
from Stardate. So what all I need is all I need are measurements so I can get the area of the base. I need to know how tall it is. So if I told you that this triangle, let me just go ahead and tell you the triangle has an area of 4 square feet. And let me tell you this thing is, let's say it's 6 feet tall. So the area formula, the volume formula for any pyramid is the area of the base times the height, that's a prism, and then 1/3. So it's 1/3 the area of the base times the height. So you know what a pyramid looks like. And we all, I don't know if you realize that there are pyramids with different shapes. Just because I can't draw it correctly doesn't mean I don't know what it looks like, right? Thankfully, I know what a dog looks like, but good God, you don't want me to draw my mutant dog. Or car, the car that would never get anywhere. Okay, so they have better computer-generated, oh please, all right. Since you gave me so much shit about my poor little pyramid, I must show you the computer-generated option of a pyramid. So let me try this. If I had, say this is a square base. My problem is I can't decide on my perspective. Okay, is that a little better? That wasn't curvy? So I'm up back here.
Yeah, I see.
So if this base was, let's say it's 6 by 6, and I know that the pyramid is 10, let's say, millimeters tall, 6 millimeters. Right? Little tiny aliens in this little pyramid. What do I need to be able to get this pyramid? It's a pyramid, I know that, because it comes to one point at one side. So I know it's a pyramid. Therefore, I know it uses this formula. What's the volume? What's the area of the base? 36. 36. Yeah, so it'd be 1/3, 36 times the height. So it's all about, you don't have to be given the original structure. You just have to look at what shape the base is in. And then if it comes to one point at the top, you know it's a pyramid. So all you then need is the area of the base times the height. 1/3 of it because it's a pyramid. It's been cut out of whatever prism it was in. So this, what's this?
120.
Yeah, 120
Millimeters cubed.
cubic. You can make it 3, Jeff. There you go.
Well, what about 120?
All right, so this is the triangle-based pyramid that these guys generated with the help of a computer. That green shape there. Now, if you will compare that to my poor beleaguered drawing of a pyramid that I drew, it's the same. So, yeah. Yeah, it is. I just didn't shade mine in green. Okay. So you don't have to be given the whole shape. You just have to see the base and how tall it is to be able to use that formula for the pyramid. Cool. Yeah, so there's the volume of the pyramid formula right there. 1/3 big ass B times H. Cool. I like it. Cool. So let's look at some of these. Have you guys ever seen that movie, The Rock, with Nicolas Cage?
Oh, that shit is terrible. I fucking hate that movie.
All right, and your value system, it would be low. I understand. Mine would be pretty high. Because I understand sometimes I want a movie where I can just turn my intelligence off, and that is an awesome movie for that. But this one problem always reminds me. I call this the problem, Nicolas Cage's green balls. If you ever seen that movie, he has to pull those little spheres of virus or whatever it is. He has to pull those out and kind of deactivate the bombs and stuff. This kind of reminds me of it. So this is kind of gross. This is a 3D analog to our cookie cutter problem. So we're going to build our way up to this one. Let's start with something not too heinous. You guys try number 18. So that's a prism, just to help you out. Try to get the volume of that shape.
Is the base a rhombus or a trapezoid?
If it was a rhombus, then all the sides should be
Different?
equal. And both sides should be parallel to the other side. So this only has two sides that are parallel.
Oh, yeah.
So that is definitely a... It's a trapezoid. Right.
Round.
Now, thank God that on my tests I'm going to use computer-generated images. My God. I understand. You don't have to remind me how horrible my drawing is. This is why, it's not the only reason why, but it's a big reason why I didn't go into art. Right? So,
I think half the fun of the test would be trying to decipher what shape we're looking at.
I think other students might call it something else than fun. Although if I did it off a test, that might be fun. So you can break this down into two parts. You find the area of the base, and then you just multiply by the length that is repeated along, right? So how do I get the area of the base?
8 plus 12.
Good. So it's the sum of the bases.
Then do like 5.
10.
Yeah, 1/2 of the height. Cool.
Yeah.
Height is 24 inches, isn't it?
No. So when you're looking at the big B is only talking about the repeated shape, the base. 24 is that height. So it does sort of suck when your base shape has its own H in its formula, but just that's why I break it up into two parts. Do the area of the base shape, and then multiply by the height of the whole thing to get the volume. So that's the base shape's height. So what do you get there? 5 times 20, 100 what? Inches square, because this is just a poor little area. So the volume is going to be 100 times 24. So you get 2,400 cubic inches. Cool. I like it. Not too bad. Especially since they're shapes that are a little easier to tell what's going on. What about this guy? Let's try one step here. I don't know if I want to try Nicolas Cage's green balls yet, but sure, man. We haven't talked about sphere volume yet? Okay, so this is a good place to do that. So the volume of a sphere is a strange formula because I can't prove it as easily as I could the area of a circle. It requires some calculus to do it. But does anybody happen to know what the volume of the sphere is? So if you have this sphere, it's got a radius of r. You know it's a sphere because I put a little thingamajig on there. Does anybody know what the volume formula is for a sphere? Just happen to know that.
Siri does.
Good guess to have pi in there. So it's definitely got a pi in there. It's got some kind of r in there. What do you think is being done to the r because it's volume?
It's being multiplied.
Probably being cubed.
Okay, I found this.
Look at you. Let me
Is
see.
that it?
Siri has the answer.
Any humans? No.
36.
So then there's a number out front that's a little difficult to explain why it's there, but there it is. 4/3 pi r cubed.
Why is it 4/3?
There you go. Again, today is full of cliffhangers that will be answered if you tune into calculus. Right? I doubt you want me to teach you calculus because then I will put it on the test. Right? Okay, then. Okay, good. I didn't think that would happen. So that is the volume of any sphere. So you got to be careful, of course. Sometimes they're going to be evil. They're going to give the diameter. So if I give you the entire diameter, if I said this diameter is, yeah, I'll give you something gross. Yeah, 17 feet. This big old sphere just appeared above the earth, and we're all like, oh my God. 17 feet across. Then what am I going to put into my formula?
Half of that.
Yeah,
8.5.
I like it. So I'm going to put in there half of 17, 8.5. Somebody help me out. Do that in the calculator, see what you get. Hopefully, guys, I think I've talked about this before. You hopefully have a pi button on your calculator. It's like 15, 16 bucks for a scientific calculator that has one on it. 3.14 don't quite cut it. Just to use my awesomenacious grammatical skills.
Come on, you know that Nicolas Cage movie's terrible.
Say again?
You know that Nicolas Cage movie's terrible.
I loved it. I loved
You
it.
ever
Have
seen
you
The
ever
Wicker
seen it or
Man?
just take Nicolas Cage?
Yeah, the like Alcatraz one. Where
Yes,
they gotta break
The
it.
Rock,
It's
yes.
fucking terrible.
No, it's awesome.
I mean, it's Nicolas Cage has made like 2 good movies.
Which one's National Treasure?
National Treasure 1 and 2.
Alright.
Yeah.
The second one's the National Treasure right itself.
God no.
Anybody get that yet?
614.125.
614.125
125.
what's?
Oh, I'm just doing the 8.5 too.
Oh, okay. So then we still have to do.
Jones one, adaptation. I like that one, and then what is it called? It's like,
How'd you figure out of 17 feet is 8 times 5?
Oh, it's not. It's 8.5.
Oh.
If the diameter is 17 feet,
Oh, you just.
we all know that the radius is half that bad boy, right?
Speed,
Cool.
is that it?
Maybe.
So some problems are going to give you diameter. You just cut that in half before you use the number.
Alright, total is 2572.44.
0.44?
Yeah. Oh, you want me to keep going?
No. What?
Feet.
Oh,
I'll be a jackass and I'll say bananas.
Feet. Cube.
Cubed. I like it. You guys are like, yeah, we know you can be a jackass. Don't make me a jackass. Cool. All right. So I like that you guys are curious about why that's the formula, but too bad you don't know enough math to see why that's the formula,
Oh.
which is unfortunate. You just don't get to the point where you can do a lot of the stuff that you use all the time. You don't know why it is that way, but that's what it is.
Oh, there's actually.
That's it.
All right, so this problem here. This problem says find the volume of the shaded region. So what they've done somehow is they've hollowed out this thing. They've taken the spherical part out of the center of this. Don't ask me how they did that. I have no idea. So it's just like the cookie cutter problem from before. You do the volume of the whole thing as if the sphere was still in there, and then you subtract out the volume of the sphere. So this is a good example of what I was just talking about. What's that 6 represent? Diameter. I like it. So what's the volume of the whole shape? The volume of the orange block? Volume of OB.
6 times 6 times.
Yeah, 6 times 6 times 6. What?
Oh, millimeter cube.
I like it. Cool. 216 cubic millimeters. So that's the block. Now cut out the sphere in the middle. What's the volume of the sphere? What do I need to know about the sphere? That it's what is what? That the radius is 3. So the volume of the sphere, I know the radius is 3. Volume of the sphere will be 4/3 pi times 3 cubed.
So like 27 times 4/3 pi.
Sure. Divide by 1/3, so it's 9 times 4, 36 pi, which will be, sure, 113.09? Yeah, so that's the volume of the sphere. So how do we get the volume of the region, the shaded region? Subtract. I love it. So it's just like a cookie cutter problem, except now they truly are 3-dimensional cookies, right? So we take 216 minus this to get what's left. Okay. So let those problems be simple as long as you